I work for the Historic England Geospatial Imaging team, and I'm going to talk about various different types of surveying that could be applied to any number of subjects, but specifically on this occasion to war memorials. And then I'm going to concentrate on structural from motion photogrammetry, which seems to be the most accessible technique and provides some very good results. So this is just a graph showing different techniques and how they can be applied to different sizes of object and complexity of objects. So up the vertical scale is the number of points you might reasonably expect to measure with the different techniques, and then along the bottom, size of objects. So our focus will obviously be in the left-hand side of that graph. We tend to think of the different techniques as being either active or passive. So active techniques are ones where you're identifying a particular point and measuring it to produce the product that you're after. Or the other concept is for passive techniques, which I'll move on to, which is basically where you measure millions of points of everything, of the whole object, and then use post-processing techniques to extract the results you want. A direct technique, the most obvious and arguably the most accessible one, is hand measurement, which I'm sure everyone has had a go at. Moving on to total station or theodolite survey, so able to cover larger areas than hand measurement and arguably more accurate over those larger areas. For landscape, so not necessarily applicable to war memorials, except for maybe parks and gardens and so on, is GPS or GNSS as it's now called, where you're measuring points on the ground related to the national grid. So as I was saying earlier, the passive techniques include photogrammetry and laser scanning. In the scales, which probably aren't our concern, satellite imaging as well. So laser scanning, I'm sure everyone is familiar with laser scanning, but it's basically a machine that will fire out a laser beam at the subject many millions of times a second, and because we know the speed of light, the laser beam will reflect, and the angles are recorded as well. So using basic trigonometry, the machine can calculate the 3D coordinates of the point it's measured. So there's a definition of it, which I won't bore you with by reading. There's various different types of laser scanning. One which is potentially more applicable for war memorials is close range laser scanning. There's different technologies, some of which aren't strictly laser scanning, are actually structured light, but they can be tripod mounted, or as we saw earlier, for the artillery memorial, mounted on a multi-axis arm, and that allows measurements to sub-millimeter, so down to tens or 20s of microns. What I'm more usually involved in is laser scanning of buildings. So scanners are normally mounted on a tripod, and you're looking to measure to or resolution of between the points that you're measuring of sub-centimeter, so a number of millimeters generally. For larger areas, there's now systems that can be mounted on vehicles, so cars on the railway and so on, which again collect millions of points, but basically the sensor's being driven around the area of interest. It's normally used for things like city mapping. And then there's further developments where you can actually wear or carry the scanner. Prices vary from the one that you can see me modelling there, which is 175,000, to the one that the guy in the video is carrying, which is about 25,000. And you get you get what you pay for, basically. Although maybe you don't get £175,000 worth at the moment for the backpack one. Then again, if you're measuring or mapping landscapes, there's laser scanning from aircraft, be they helicopters, planes, or potentially drones. So there's the advantages of laser scanning. You can measure pretty much anything that a laser beam will bounce off of. It's very fast, millions of points per second. It can be, well, you can choose the resolution, but it can be very high resolution. Most laser scanners actually have a camera built in, or you can have a camera mounted on top of the laser scanner and use that to apply a color to the measured points. Disadvantages, very large file sizes, which even with the dedicated computers we have, we can struggle with. We're constantly having problems with storage of the scan data as well. Scanners are expensive. That 15,000 will buy you the lowest end of laser scanner, but generally you're talking 50 to 60,000 and potentially 100,000. For the post-processing, you need specialized software, a certain amount of knowledge on how to use that. And then when it comes to disseminating the results, you still have to either compromise the resolution of the data, or the end user needs a fairly sophisticated computer. And as I always like to remind people, if you want a line drawing, that still at the moment requires manual intervention. There are systems that will extract lines from laser scan point clouds, but they tend to be a jumble of unstructured lines which need so much editing that you might as well have just drawn it from the beginning. Not applicable here, but there's systems that will extract like cylinders and joints for process pipe and so on very effectively. So moving on to the main focus of the talk, which is photogrammetry, just because that has become the most accessible technique, I think. And it's pretty much applicable to the same range of areas as laser scanning, potentially larger areas from aerial photography or satellite imagery even. So there's another definition, and it's mostly science, but there is a certain amount of art to the process. There's another one, more recent one in the, I'd recommend, as well as Historic England guidance, there's a good suite of guidances from the Survey Association. So I'm sure everyone's heard of photogrammetry, or hopefully they have, and are familiar with the fact that it's based on stereo photos, which is basically using two overlapping photos which replicate the way we see in 3D, so a left eye and a right eye. And then there's geometry involved in calculating the positions of points in the two photographs. So we're going to move on to talking about multi-image photogrammetry, but the fundamental is still based on the overlap between two or more photographs. And so this is just some previous work we did on rock art before the advent of structure from motion. So I'm sure everyone's heard of structure from motion. That's part of the process, but it should really be called multi-image photogrammetry. It's basically using a large number of images to measure whatever the subject is. So the advantages of photogrammetry is that it, like laser scanning, it's applicable to any type of surface, anything that you can take a photograph, basically. As well as the end result, you've got an archive of hundreds of photos of the subject, which could be good for monitoring condition or whatever. These days you can use pretty much any camera. I'll go on to show that better the camera, the better the results. In the old days when I started photogrammetry, you had to have a calibrated camera, and that was always a bugbear because it was difficult to get them calibrated. You always had to make sure you had the right calibration information for the particular photos, and it made it quite inaccessible to non-professionals. I would say it definitely generates high resolution 3D point clouds, potentially higher resolution than laser scanning, depending on the resolution of the input photos. And the software can be from low from free to low cost to reasonably priced, which is one of the reasons it's become so much more popular than photogrammetry used to be. I guess this is a disadvantage, but not so much these days when digital photos are so easy to take. In the old days, if you had to get all the photos processed, you'd want to be as economical as possible about the number of photos you took, but you do obviously need lots of overlapping photographs. Unlike laser scanning, which will work on any surface, photogrammetry does require some kind of texture on the surface, so it wouldn't work on these white walls, but a war memorial with the different variations in the colour in the stone, or the algal growth or lichen or whatever is a perfect subject. As I'll move on to show that basically you can get results from bad photos, but if you want accurate results, then you need good photos. So as it says there, rubbish in, rubbish out. So probably the most popular software that people are using is Agisoft Photoscan, probably because the standard version is only 130 odd pounds. Although if you want any scale and various specific outputs, then you'd need the Pro version, which is around £2,500. Just I should point out that there are other structural motion softwares available, and some which are free, although they do tend to require some kind of familiarity with command line interaction. So this is just going to be a sort of continuous slideshow of the workflow in structural motion softwares, and specifically Photoscan. So obviously the first thing is to import all your photos. This next point they go to is basically comparing pretty much every photo to every other photo to find common points between them. And this isn't the common points that you or I would pick out of a photo. This is down to pixel level using particular algorithms, but those blue dots are the points that it's found in a particular photo that it's then going to try and find in all the other photos. So that's just showing it from different photos. And you can see there in the middle of the inscription panel, there's what you or I would appear to be just a plain surface, but the software has found a group of pixels that it can match, or hopes to be able to match to the same area on another photo. So once it's done that, it produces what is called a sparse point cloud. So that's a cloud of the points that it's found that match between all the different overlapping photos. And from that, it can calculate the positions where the camera was when the photos were taken. So all those blue squares are the different photos that were taken around this particular war memorial. From those camera positions, it can then go back and work out coordinates for pretty much every pixel in the photographs and produce what is called a dense point cloud. The dense point cloud can be as sparse or as dense as you want to make it, depending on the settings. But the dense point cloud is the equivalent of the laser scan point cloud, but it's normally just the basis for producing so that's just a close-up of the dense point cloud. The point cloud is normally converted into a mesh, which is all the points connected by lines, and those lines form triangles, and those triangles have surfaces. And the point of so that's, hopefully you can see that there. Point of having the surfaces is that you can then apply a photographic texture to the surface and get a much more photorealistic model than basically the dense point cloud, which is each point is given a color, but the gaps in between obviously don't have a color. And then we can just zooming in to see a bit of the detail. You can see on the edges there, whoever did this had some slight issues they probably didn't take enough photos of the actual corner. So there's, I don't know if you can see sort of what looks like broken stone, but it's probably just an artifact of the model. And then one of the easiest ways we found to disseminate the results is in a 3D PDF, and I'll show you some of those later on. But if you wanted to actually take measurements off the results, then we can actually produce what's known as an orthophoto, which is an orthographic projection of the model, which means you've got a 2-scale image that can be used for measuring or for any other purpose that you might want an image. So this is some examples that one of our team did where they used different types of camera, from mobile phones up to high-end digital SLRs, and that was on various war memorials around our offices in York. So I'll just show you one of the examples here. You've obviously used an iPhone and an HTC, so you can have a look. But basically we've got this 3D model, which, if I remember rightly from the slide, only took about 15 minutes to photograph and another half an hour or so in the office. But as you can see, we've got some issues here. There's, because he wasn't able to photograph the top of the memorial, we've got this rather ugly hole in the top there. But there are ways of getting around that. I mean, we could have edited out these various bits as well. Just find the PowerPoint again. So yeah, as it says there, top needs imaging from a step ladder. Wouldn't necessarily recommend a step ladder. We've got a extending pole which we can put the camera on, and then a remote control of the camera, a bit more health and safety aware. There was difficulties getting around the memorial, and although scale measurements were taken, because he was using the cheaper version of Photoscan, then he wasn't actually able to apply those scales. Although, as we said, if you do the initial processing in the cheaper version, you can then open that in the more expensive version and put in your scale measurements. So this is another example using a off-the-shelf compact camera, though admittedly quite a good one. And you can see longer time taking the photos, mainly I expect because it's a bigger memorial, and then a bit more time in the office because of basically masking out the sky around the memorial, which was causing issues around the edges there. So this is showing the detail of the inscription. And one thing to point out here is that one way perhaps of reading illegible inscriptions is that once you've got this 3D model, you can bring it into software. You can actually manipulate the lighting yourself, or use just the surface without the texture on, so you haven't got the algal growth or whatever confounding your attempts to read the detail. But just moving the light around can help to read the inscriptions. So that's a middle range camera, and if we move on to the next one, where this is an even larger memorial right near our office, and a good quality full frame digital SLR has been used. The photography took similar sort of time, but then more time was spent in the office masking the images. Again, this one, because it's so high, there was no way of getting coverage of the top of the memorial from the ground, so you could use a pole or potentially a drone, although where this memorial's located, you'd probably have to close the road before you're allowed to use a drone, so that's not necessarily a possibility. And then the other issue was actually gaining access to the land at the back of the memorial. So when I show you you'll see that although there's good coverage of the front, including the Stone of Remembrance, when we get round to the back, then there's a here be dragons sort of element. But I mean, none of that is insurmountable. It's just probably a case of negotiating access to that land in advance. So here's some general rules to consider if you want to try and do structural promotion yourselves. So I suppose it sort of goes without saying, but the images need to be sharp and in focus. And to achieve that, you might need to use a tripod. And it's always worth checking every photo before you put it into the software. Try and use a optimum aperture. If you're using a tripod, you can use a smaller aperture to get better depth of field, but that can compromise the quality of the photos. So the corollary of that is that if you're in low light, you can use a wider aperture, but that will affect your depth of field. Modern digital SLRs, you can ramp the ISO right up, and you can probably get away with going pretty high, but try not to go as high as it will automatically take you. If the camera allows it, shoot RAW, because that is the equivalent of the analog negative. You can go back, you convert the RAW to TIFF or whatever, but you can basically go back to the RAW to change various settings in the way the TIFF is generated. Use a fast shutter speed, basically, because you don't want to get the camera shake or blur due to camera shake. And that's especially the case if you're handheld, or even more of a case if you're using a photographic mast. Modern digital cameras have image stabilization, which is basically moving the sensor relative to the lens, which will confound the photogrammetric algorithms. And I think this is said twice, but it should be emphasized that on no account crop the photos, because you're changing the geometry of the photograph there. I sort of mentioned this earlier, but definitely any point you want to measure has to be in 2 photos, preferably a lot more, maybe up to 10. I touched on this earlier as well. If you want to get a continuous model around your war memorial, then you need to be basically taking photos opposite the corners, so you've got something bridging the gap between the faces. Photographing in flat light is the best bet. If you want shadows, you can introduce them digitally at a later stage. Yeah, again, don't crop the images. Don't do things like sharpening as well. And as was said earlier, you'll get something out of bad photos, but the accuracy will be compromised. So more suggestions. Use the largest physical sensor size you can afford. Don't just rely on the number of pixels, because you can get some cameras with very small sensors with a large number of pixels. So each of the photodiodes that represents a pixel is incredibly small and can start interfering with its neighbors. The priority should be to spend money on lenses rather than the camera body. And one warning about cheaper mobile phones is that the sensor is sometimes just glued on with a blob of glue, so isn't actually square on to the lens. So here's another example, which was pretty successful. The Wagoners Memorial at Sledmere, we've already seen some images of that. So this is I'm sure everyone's familiar with it, but quite a remarkable monument, reminiscent of Trajan's Column, and has these reliefs of the Wagoners who were in a particular regiment formed by the can't remember the name of the lord, but from the Sledmere estate. That one, yeah. So that's just a detail of that 3D model. Showing another one showing the mesh there. So that just brings me to my summary. So there's only a number of different geospatial imaging techniques, but structural motion is relatively low cost and eminently suitable for recording war memorials. With a certain amount of instruction and practice, it can be undertaken by non-specialist surveyors using equipment that's readily available. One thing I don't know whether I emphasized, was that the better the computer, the quicker the results. And if your computer's particularly underpowered, you may find that it gives up rather than produces the results you want. There's free trial versions of various softwares, or just open source software that's free for use by anyone. If you wanted to do a workshop, you can get the 30-day free trials of the fully featured version of Agisoft Photoscan, and I imagine you can with other softwares. The 3D point clouds are of use themselves, but they can be made into textured models, which could be used for 3D printing. And the outputs can be easily disseminated. I've shown you a load of 3D PDFs, but there's also Sketchfab where you can upload your 3D models, which basically you can then link through from your website and allow access to anyone. And then all the photography, once you've got your model, don't discard your photographs, because they have intrinsic value themselves, but also we don't know what's further technologies will come along down the line that those photographs could be used for.